is very fine, well, sediment basically, falling out of the outcrops.
And then it's getting kind of like a softer edge over on the left-hand side. Yeah,
indeed. Like where blocks of material have come down the slope, have sort of broken off the sharp edges and made it softer.
Yep, Deb says that this stair-step pattern of fracturing is amazing. Yeah, I agree. It is amazing.
It is a beautiful characterization of an unusual sort of fracturing that we have not yet seen before on either legs 1 or 2 of these expeditions. So,
coming up.
Hey, geological first in terms of structure.
Biology.
And we have biology. Yippee.
On your sonar, let me
So,
know you're
Patty,
comfortable
this is
with
Scott.
Copilot.
I get the impression from everything I'm listening to that this is not the geology you expected to see down here.
That's true,
Hey,
Scott.
Nev, let me know when that ship move is done.
This is pretty exciting.
If it's done, you have maybe 5 more meters.
5 more meters?
Well,
We have a few nicknames for this feature.
Devil
Devil Stairway, Stairway to Heaven.
To heaven.
We want to be careful about quoting that, though.
Okay. We're in good shape then. Yeah, I mean,
based on what's been happening lately with litigation
Zoom into
related
it.
to that song.
Oops. Oh, that's true.
give it a small break and then maybe do
Okay,
another
as we
5
look at
meter
this
move.
rock.
I don't think if it's underwater.
Sorry, you can zoom in.
Yeah. Okay,
All
folks.
right,
Let's
here we go.
talk about
Focus.
the biology for a sec.
Can I hold partial?
Okay.
Can tell we're a bunch of old rockers.
Gotta keep upward thrust.
So we are zooming in here on another bamboo coral. This is a branched bamboo coral, so the first branch one I've seen today. And one of the ways that we are able to narrow down the identity to species or genus is to determine how the branches arise from the skeleton. So you can kind of see the tissue is transparent. So you see the white skeleton, then you can see there's some black dots. Those are called nodes. And so one of the things we look for is, do the branches arise from the white internode part or from the black node part? And it looks to me like this is an internodal brancher.
Well, you can really see the internal morphology of these polyps really, really clearly.
Sure can, and you can also see the reflections of the sclerites. They kind of look like needles or rods. They're embedded in the tissue, and there are lots of them, so you're not seeing all of them. But sometimes we see enough that we give some sense into the identity of what we're looking at. So what I'm seeing here is that there are some rods that are just between the tentacles, but they don't actually rise above. So they don't have these sharp intertentacular needles. So that's one thing that can help us identify it.
Beautiful.
Definitely internodal branching. I can see there's a new small branch coming off on the far left there. So, tentatively, this is the genus Keratoisis. That genus is so named because it's branching bamboo corals of a particular subfamily, of which this is one called the Keratoisidinae, that branch at the node. Wes Watling and I and our students are
Where am I?
doing a lot of work, and we know that there's going to be many more new genera based on other characteristics that's not quite ready. One thing that's interesting I'm seeing here at the base of the pulse, there are two long sclerites that are oriented parallel with the main axis, the main branch, and perpendicular to the polyp. So that might be
going the
interesting.
wrong way.
So let's have to say anything about what this is. Oh, unfortunately, he's gone off the chat. That's too bad. Thanks for the Zoom. That was nice.
Okay, let's get it back up.
Thank you, Scott.
Okay. Scared me there for a second. Sorry about that.
Now, it does look like the slope is a little gentler here. Still
We're not moving
covered
at all.
in
No,
part
we're not.
with rubble and in part with what looks like fractured rock that may actually be in place. We do have quite a lot of what looks like coarser sediment than we saw earlier in the dive, mantling part of the rock surface. And there are a lot of places right here in the middle of the screen where the rocks are sort of broken open. And they look granular when we get a close view. Watch lead pilot.
Go ahead, watch lead.
Wonder if we could zoom in on some of these light areas just to see if the granular sediment is actually coming from this material.
Okay, we can zoom in.
That's partial zoom.
Yeah, sure looks like there's more of this granular sediment coating the face of this part of the rock wall. And looks like these blocks of rocks have been rubbing against one another. I still don't see any real layering in this to suggest that it's sedimentary, but the texture of the surface of the pieces of rock does look more granular to me. There is a little bit of coating on top by sediment, but granular sediment, so a little bit coarser sediment, maybe sand-sized. But I don't know, it sure looks like it's coming from the very rocks that we're looking at.
It sure does.
And as we were zoomed in, you could see a lot of little white circular grains that are these foraminiferal tests or shells, and they are about sand-sized to large silt-sized themselves. So this little area looks like the rocks have all sort of broken apart and started tumbling down slope a little bit.
Pretty good, huh?
Yeah, we're not moving at all.
Mm-hmm.
We
The
can
black
do
ones
another 10
are somewhat
meters.
coated
Let's get
with
called in, we'll push
manganese
out.
oxide, and then you can
Same
see the
heading?
lighter
Yeah.
color
You happy with
beneath
heading,
that
pilot? Looks
Yes.
good to me.
down lower on the slope.
Everything looks exactly the
Oh
same
yeah,
right
this
now.
is real gentle the slope now.
I'm seeing pretty soft returns.
Do you want
Yeah.
more than 10?
Yeah, I'm thinking.
Pilot, if you
hold on.
if you could turn the ROV into the current, maybe, so we could see how steep the slope is
Sure.
right in this
It's
area.
starting to get a lot shallower
A lot
here.
flatter. Yeah, I
Yeah.
thought so.
Yeah, we could
We go 20.
yeah, we could do 20. Yep.
All right.
Okay, off to the edge against the darkness of the water. It looks like
Bridge,
still
ROV nav.
part looks like 45 degrees, and then maybe 30. Oh, thank you, pilot.
Can we get another ship move, please? 20 meters, bearing 340 degrees, decimal 2 knots. Thank you.
Anybody see any fish out there? Yeah, we've only seen a couple fish on the dive so far. Okay, thanks, pilot. I
Yep.
guess we can continue on up.
Yep, we just put in a move, so we're going to be on our way, and I think we'll be able to start moving horizontally on high pack a little faster now.
Okay, thank you
So,
very much.
We'll make up the pace.
Okay, biologists on shore. Shirley has gone out to lunch, so you're going to have to help me here if we see something really cool. So we're seeing a lot of cobble-sized and boulder-sized rocks
Good
on
zoom
a
in.
sedimented surface. And we have a little white object, on this rock that is covered with manganese oxide.
Okay to zoom further.
As we get a close zoom, get a better look, we'll hear from our shore-based scientists as to what this tiny
That's
little
sexy.
critter is. Okay,
Hi,
Scott.
Patty. I think this may be a baby bamboo coral. It's definitely an octocoral. You can see that because it has these pinnate tentacles with little tiny side branches coming off the main tentacles. And the thickness of that white skeleton suggests to me that it may be a bamboo coral. It's hard to tell from this angle, but it's a pretty good guess.
Okay, thanks, Scott. Very, very young. I think I only see 4 or 5 polyps on this.
Okay, let's assume partial. There's a little
Yeah, so I referred to it as a baby. You know, the growth rates of most of these deep sea corals and bamboo corals is really quite slow. So we know they get a minimum of decades old. Some have been aged at hundreds of years old, and some of the black corals at thousands of years old. So there's some old corals down here. And I think maybe you have a crinoid down to the lower right.
Okay, yep, we'll look. Thanks, Scott. Yeah, we're setting up to take a look at this more orangey animal on a little cobble.
There we go.
Boy, all of these rocks have been here a long time. They have that characteristic cauliflower-like surface cover of manganese oxide. So, biologists on shore, what are we looking at with the cirri on the bottom? I think I know.
Patty, are you talking about this brownish-colored crinoid?
Yeah. That we are zooming on now. Crinoid, right?
Right. So this is a crinoid, another echinoderm, closely related to the brittle stars and the sea stars. And the difference with this one is it's kind of flipped its body around so the mouth is facing up. The mouth is facing upward in the center of those arms that you see extended. This one looks like maybe it's had a fish been nibbling on its arms. You can see that 3 of the arms are definitely shortened. When they can grow back, you can see there's a very white little tip at the end. You see off the main arms, there are these little side branches. Those are called pinnules. And then you can see kind of transparent, but arising from the pinnules are those little side structures. Those are the tube feet. So those are the tube feet that you would see underneath a sea star, for example. And it uses those tube feet to flick little food particles out of the water column. And actually, this is really nice. On that back arm, you can see looks like a red line that's kind of zigzagging its way down the arm. That's the groove that goes down towards the mouth that is in the center of those arms. That's in the center of the arm. And then it hangs onto the rock by these structures called cirri.
Oh, thank you, Scott.
And I'll push out ahead, and I think
Okay.
we'll leave the next ship move up. to our
Yeah,
next
we
watch.
can move up the slope. Thank goodness it's a little bit less steep here.
Yeah, we'll be able to move quite a bit quicker now, I think.
Okay. Yeah, we've got a lot of sediment here and scattered boulders and cobbles. Bigger ones at the top of the screen coming into view now. Oh, is that another black coral on the left?
Cereals should be leveling out.
Better take a look and get the real biologists to describe it. And we have waiting in the wings our next shift
Holding.
of pilots, navigators, and co-pilots.
This looks like this black coral that we've seen a number of times now, and it may be in the genus Bathopathes, and one thing that's kind of interesting about it is that yellow color. Many of the Bathopathes we see have a more orange bed or are transparent to white, so the yellow is quite interesting.
Thanks, Scott.
So Scott, that one looked like it had secondary branches along it, which is more Stauropathes-like, isn't it? I don't know if Bathypathes does that.
Yeah, I agree, Chris. I wasn't sure if I was seeing branches being folded over in the current or if there was that secondary branching. But if that's what you saw, then you're absolutely correct. That would be a characteristic, or that would suggest the genus Stauropathes rather than Bathypathes. And one thing that makes that interesting to me is that I'm not sure that Stauropathes doesn't start its secondary branching when it's very young. So I wouldn't expect to see it look like a Bathypathes and then later look like a Stauropathes. There is a genus that is known from the North Atlantic, just described a couple of years ago, that is called Telopathes. And basically, those look like large branched Bathypathes. And if this was a Telopathes, then this would definitely be a new species. There's certainly none that are yellow. And I think we collected one on Lake 1, one of the orange ones. You'd have to remind me, or somebody would have to remind me.
Oh, thanks, guys. Just to let you know, the pilots had told us a little bit earlier that although we had a pretty strong current coming from the left going toward the right across the screen, that current has subsided considerably. So, not sure if what we just saw was affected by currents. We have a new crew in the front row.
Hi, watch lead.
Hey, watch lead. Yep, pilots, do you guys want to introduce yourselves at this point?
Yeah, we can do that.
Oh, great.
Just make some adjustments here.
Yep, getting themselves settled just a little bit, and we'll hear from our new group.
Yeah, hi everybody. Good afternoon or good evening or good morning or wherever you are in the world. And my name's Jeff Williams. I'm with the Global Foundation for Ocean Exploration. I'm your pilot for the next couple of hours. The team here in the front row to the left, Richard Stoner is stepping in as navigator. To my right, Don Liberatore is flying co-pilot. Tara Smithy is over in the corner working the video for us. And video engineer Roland Bryan is in the back row doing our clipping. So that's our team that's operating and maintaining this equipment for you guys. Hope you have a great dive with us.
Thanks very much, pilot. And I'm Patty Fryer. I'm a marine geology research professor at the University of Hawaii in the Manoa campus on Oahu. I'm part of the Hawaii Institute of Geophysics and Planetology. And we are coming to you live from the NOAA ship Okeanos Explorer, America's ship for ocean exploration. And we are here at the Mariana Trench National Marine Monument. We're looking at a fault wall, a scarp, that is about 300 meters high.
Looks like we're almost looking
about
down on you
a
there,
third of the
Jeff.
way
Maybe
up
you need to push out a
this
little
scarp.
bit.
Okay, what's the direction
We're
moving
looking
now?
at
Our co-pilot.
What I was told
a
was about
series of
340,
boulders
what they've been
and
moving up slope.
sediment that are mantling the scarp.
He said
and
they were
we
doing
are occasionally taking
20, 25
zooms
meter
in
jumps,
on
but now
benthic
that
animals
the slope has flattened
that
out a
are
little
of
bit,
interest
we
to
could probably
the
do a little bit better.
biological lead who's now
Okay,
down
copy
in the
that.
galley having her lunch,
pilots, hopefully
but
you've got
also
good,
to the
comms with me.
company of biologists on shore who are joining us live through a chat room, and also you'll be hearing them speaking to us and describing the animals that we're finding on the seafloor. Expeditions like this is the 2016 deepwater exploration of the Marianas, are only possible through successful partnerships and collaborations.
Roger that. Got you loud
The
and
particular
clear.
mission that we're on now is designed and supported by NOAA's Office of Ocean Exploration and Research. The ship itself is operated
Drifted
by
off a
NOAA's
bit.
Office of Marine and Aviation Operations. And our current expedition is part of a 3-year campaign to address the Pacific Monument Science, Technology, and Ocean Needs. As an acronym that's CAPSTONE, that stands for this particular campaign, and it was designed to address the fundamental need of resource managers to better understand the deepest parts of the nation's
roger that.
marine monuments.
Okie doke.
Pushing up a little bit.
Some of the key
All right.
partners that you have
David did make the comment
involved
that,
in this
time is
effort
not on our
are the
side
NOAA's
today.
National Marine Fisheries,
okay.
NOAA's Marine National Monument Program, the NOAA's
think it
Deep
was
Sea
yesterday
Coral
either.
Research and Technology Program, NOAA's National Center for Environmental Information. And aside from exciting missions of exploration, the way the Okeanos Explorer operates is quite unique. All of our operations are community driven. That
Don,
means
let me get a little bit out in
scientists
front
on
of you
shore
here before we
get together
start
and discuss what
Roger
might be
that.
appropriate
Still
targets for dives with the ROV that we're operating out here. Then we have
Yeah, roger that.
discussions that involve everyone who is potentially interested in taking part either on shore or on the ship or from their home institutions, and dives are planned and proposed by members
Oh,
of
is it
that
happy with
group
your sonar?
and
You're
carried
quite
out
tight
here
in
aboard the ship.
on the 10-meter one.
So
Yeah.
our
Yep,
ROV
that
operators
looks good there to me for
are,
now.
as they said,
Okey-dokes.
part of the Global Foundation for Ocean Exploration, and they not only operate and maintain the vehicle, but they actually build it and engineer it. And one of the folks that you didn't hear actually
And
introduced
just to reiterate, I have got a
is
note here
down
saying,
below decks
if possible,
in a
do
very
not
hot
open the
room,
port bio box.
watching
Roger
the
that.
winch,
They've got something in there
which is
that
a big spool that
Right.
has the cable that is attached to our remotely operated
If it can be
vehicle
avoided.
through
Roger.
the secondary vehicle Sirius, which flies
Car,
above
let's
the
take a zoom on
ROV,
this,
Yeah, that looks a
whippy
little
thing.
weird.
and it has a tether about 30 meters long
your mark.
attached to the ROV.
Okay, zoom partial.
And what we do is we look at the seafloor, zoom on biological,
Holding partial.
unique creatures on the seafloor, as we're doing right now. And I will let our shore-based biologists tell us what we
zoom in
are
some
looking
more.
at. Beautiful.
Thanks, Patty. This is great. So this is an octocoral, the genus Metallogorgia, the family Chrysogorgiidae. So earlier we saw an adult Metallogorgia skeleton, and I described it as being about 1 meter tall with all its branches and polyps at the top. It was dead, so we didn't see any polyps. But I said that the juvenile phase had small tufts of branches
Let's see if we can
up
zoom in a
the
little
stalk,
bit
and that's
on the
exactly
turtle
what we're
star.
looking at here.
Roger.
This is a young colony of Metallogorgia, and once it reaches its adult stage, all those little branches going down the stem will disappear, will fall off, and you'll be left with a tuft
Okay, to
at the
zoom.
very top, kind of like a dandelion. So
Oh,
it took us a while to figure out that that's what was going on, that there were these growth stages. And if nothing else, this highlights the importance of being able to make collections of different sorts of things, look at them morphologically and genetically, and learning how they may or may not change as they grow. And what you're looking at there on the colony is a brittle star with its arms all tightly wrapped around the colony. This is the brittle star in the Ophiocreus oedipus. And Les Watling and one of his former students, Claire Mosher, have a really interesting paper documenting that there's this very tight association. This brittle star species is only found on this species of coral. You never see it on the rock.
Nice.
You never see it on any other corals. And we never see a live Metallogorgia without that brittle star. It's just a fascinating thing, and it raises all kinds of questions
let's
like,
go for what?
how on earth does the larva of that brittle star find that coral?
Teaming up.
Thank you,
And
Pilot.
we found them really, really small colonies, and even those small colonies have that brittle star on them. It's just a fascinating question that it's a challenge to figure out hypotheses and ways
Pretty
to sample
steep
to measure it.
thank you, Scott. Wonderful
How
explanation.
far are you from the wall, Don?
About 20,
What,
looks
What
like
we're
about
seeing now in the geology is
25
quite
meters, maybe.
different from
All
what
right,
we
why don't
just
we move 10 meters towards the
came
wall?
away from. And here we have very obvious horizontal layering and also fracturing
340.
in this rock surface. And this is very characteristic of sedimentary rock sequences. We've been puzzling over what is exposed in this wall now for quite some time based on the structure. And we're coming to a contact with yet another
Looks like another little plateau. That's what
very
we're
different
get a vertical
textural
wall and a little
and
slope, and
a
stair
heading
step
of
sort of looks like, huh?
340 and a
Oh,
speed
what
of
shall I
0.2
say?
knots.
Lacking in any sort of layering material above this contact.
Good
So it's a
copy. Thank you,
very
Bridget.
distinct contact here between two quite different rock types. So let me write that in the chat before we move. And we're at 1809 meters where we got this contact. And
Okay to move up,
339 heading. So what we're looking at now looks like
I don't think she copied
almost a coarsely granular surface of the slope. Almost
yeah, it does looking
no
up at
fracturing
Sirius
in
there
this at
from
all.
its camera. Looks still pretty steep
Yeah,
here.
it does.
I think that was just a momentary change in the slope.
What's this staining tower? Can we zoom it? Partial?
And we're going to zoom on something. I don't see anything there. What do we see here?
Just different color rock, really.
I think it's just lighter rock,
Brownish more than black.
sort of buff to brown.
Yeah.
Very, very typical of the sort of
Full light.
rock surface we see right where manganese oxide fades away into fresher rock surface.
Don, could we tack another 10 onto the move that's already underway?
I think so, yeah.
All right.
As long as you don't stop too long.
Shirley's back.
Yeah.
Take a look. See,
Yeah.
we got.
And she
So,
is
now
wondering
let's
what
just add 10
we
to that
did
move.
with the rocks.
Add 10 meters to the current move.
Bridge, this is Nav.
And she's also got her warmer sweater. It's really cold
Bridge,
here
could I add
in
another
the
10 meters to that
operations
move,
room
please?
today.
All right,
I've got a
now
sweater and my fuzzy jacket on and want a blanket around my leg.
Good copy. Thank you, Bridge.
Brr. Okay, granular. Oh man, this
What
sure
the
looks
heck
like
is that? What
sediment.
is that?
This looks like sediment. We just came up a layer of a contact between beautifully horizontally layered material and this stuff, just sharp as a knife edge and very horizontal. And this sure looks like coarse sedimentary material.
Have we seen this particular
Oh.
biology before?
Have we seen this critter before, Shirley? Should we keep on a going? For a quick zoom?
I think we ought to look at it.
All right.
Why am I surprised?
No, I think we ought to look at it. I don't know. I've been going for
Oh, there's a
20
jelly.
minutes, so
What
I
is
don't
that?
know.
There
yeah.
is a
Yeah.
jelly.
floating by.
Let's
Why am I not
zoom
looking
partial
right?
on the jelly.
This is the
Same
same
as we
jelly
saw
that we
earlier.
have seen earlier and
The
yesterday.
cornate jellyfish.
Cornate, right. It's got his tentacles all
Darkly-
tucked in under its bell.
Darkly pigmented,
Mm-hmm.
so that when it eats bioluminescent
That's
prey
right. Yep. The other
can't
things
see.
can't see it
and eat it.
and eat it. Bioluminescence is a draw for many of the animals of the deep.
Okay. Bye-bye.
There's a stalk behind it too, but it looks like it might be the sea pen that we've been seeing before.
Okay. Let me go over and take a look at the thing
Yep.
I was originally going to look at, and then we can look around some more. But I understand,
Oh.
watch lead, we need to keep moving today. Is that?
Yeah.
Yep.
Yep, we do.
All right.
We do, thank you. But
So-
we could do a quick zoom on
So
this
is that
guy.
that fan in the distance, folks,
Let's, do
similar to what we've already
partial.
seen? Bathypathes, we've already
Maybe I
seen
can
that.
just float it from here.
Looks
It's
different.
something we've
Holding
seen.
partial.
Have we seen that
Thanks for
today?
I can take a
Okay.
bit more
Yeah.
if they need.
Yeah, Tara thinks we did.
Sure.
Tara Smithy.
All right,
thinks we did.
zoom more, pilot.
Stand by. Okay, go ahead. hold that, please.
Anyone want to weigh in on this? I think Chris said bathy-pathies.
Yeah, Shirley, this is a black coral, and Chris has noted that it is likely the genus Bathypathes. We were having this discussion a little bit earlier that there's another genus called Telepathes that looks just like this, and when it gets to a certain size, these primary branches that are coming off the central axis start to have secondary branches coming off of them. And until it gets to that age, you can't determine from a video the difference between them. But
Okay.
for now, this is fine to call it Bathypathes, black
Okay,
coral.
great. Thank you.
Very coarse-grained material on the surface right now, with some finer sediment among pebble to granule-sized surface, and we're
Richard,
coming
how's
up
our separation?
again to more rocks. And
We looking
what
good?
is
Stalk
this?
crinoid.
Stalk
Yeah,
crinoid.
stalk
This
crinoid.
is
You're okay.
just like,
Okay.
yeah,
Yeah,
I'm
similar
fascinated
to the
by
other-
these,
yeah.
as they
We,
have
take a quick
additional
zoom on this.
Sure.
extensions from the main arms. And I think I wrote down what
Did you
this
zoom?
is, but I forget.
Go ahead. Hold that.
So this is great. This is an adult Metallogorgia. Just
Oh,
a
this
few
could be
minutes
cool.
ago, we
Yeah.
were looking at a juvenile, or
Oh, you're right.
Spotling and I would call it a teenager because it had multiple tufts
Oh, there are two of
branches
them.
along the stem. But here you can see the adult stage.
Yeah.
Those branches that were on the main axis have
Oh,
been
this is
dropped
cool.
off, and all that's left are the spray of branches right at the top, and that brittle star has moved from the lower branches to the top center, and I can see just behind it there's a
There's
second
another one.
Metallogorgia
Yeah.
just in the distance, and this is not
Do we have?
unusual.
Okay,
When we
no
do
worries.
see Metallogorgia, and we're in a perfect depth range
keep
today, see Metallogorgia, we often see several of them. And I'm going to call this the species Metallogorgia melanotrichos, and the reason I can say that with some confidence is that we've collected samples of this species all over the world and done the genetics and found that it seems to be a true global cosmopolitan species.
And so that that brittle star that you see on it now, that's the one that's typically found with it. I know on the dead one it looked like a different one.
Time to keep moving, Don?
Yep, roger that.
Right, so the brittle star that we saw there is
Sure.
Ophiocrius
It seemed to
oedipus,
work out
and
okay
that's the
there.
brittle
Copy
star.
number
That
20
species
and
lives only on
bearing
that coral.
340.
Roger.
Bridge, this is Nav.
Yes, Scott, when you get a chance,
Hello,
could you
Bridge.
write the
Could I have the
species
same
name,
again, please,
the
which is
oh wait,
another
yeah, the
move
genus
of
and species names of
20
both in there,
meters
please, in the
with a
chat log,
bearing of
please.
340 and a speed of 0.2
Yeah,
knots. please.
Les had written it for the previous one that we saw while you were at lunch.
Oh,
so it's
okay.
in the event log.
Okay, got it.
20
Thank you.
meters, yes.
Oh yeah, I see it now.
Copy, Bridge. Thank you.
Okay, we are, as we rise up the slope above the coral, we see very coarsely granular exposures that right now do appear to have a very faint layering. We just rose above some interesting structures that had sort of rounded surfaces, but also there seem to be slabs of this material that have dislodged from the wall of this fault scarp and slid down on what is probably almost a ball bearing like surface of these coarser grained sediments. I'm pretty sure these are sediments. I think this is a continuation of the material we saw immediately above that beautiful horizontal contact with more finely grained material, sedimentary material below this layer. As we rise up here, I'm sort of surprised to see animals that are benthic, that live on the seafloor, attaching themselves to this stuff that seems to be so easily broken up
off, yeah.
and on a very dynamic fault scarp would be sliding down. Oh gosh, we are looking
look
at
at
a vertical
this.
fault
Oh
right
my
in front of
gosh.
us with rocks that have slid in. I don't want to guess here, but it looks like a very high angle fault, and you can see very obvious layering in the rocks.
Go ahead. Yep. Let me back up a little bit, maybe give you better context. You're talking about this that's just coming into view now, yeah. Oh, it's all right. Let's do this.
I'm going to try to get a zoom on that vertical fracture. It looks like there's offset. Certainly the horizontal lineaments on the right do not match up with what we're looking at on the block, and just see if maybe we can get a sense of the offset on it.
Nav, how far along are we on that 20 meters?
Okay, we started at 18, so we're about 3 minutes into it.
So right,
If
just
there
in the
is-
center
That's
there,
about
is
another
that the
2 or
fault?
3 minutes.
Yeah,
Actually,
I don't
no,
know
over to
if
the
they,
left.
Okay.
If they're going to spend some
Left side of
time
the
here, we
block.
may
The
have
left
to
side of the
stop them.
block.
Yeah.
Just want to see if it's a continuous line and that very obvious indentation, horizontal indentation.
Position-wise, you can see
It
we're
kind of
just
looks
coming
like there's a
to,
white streak
where we should
at the
be.
same level
Roger, copy.
of what we're looking at as a dark streak, which is just basically an indentation, horizontal
Excellent. Looking at
indentation in
as if the lay
the
back
surface
is
of the
about 4
block on
minutes
the
after that.
right-hand side of the
Okay.
screen. It looks like
Based
it's
on what's written
continuous
down.
with the block on the left, so there may not
Yeah,
be
it's about what
any
they had yesterday, too.
offset
Similar depth and
on this vertical fracture.
conditions.
Hard to tell, though. Oh, thank you, pilot. That's good.
Great.
We can see
I think just to put things in
changes in the
perspective, pilots, we
grain
have
size in the
340
layers
meters to
in
cover
this material.
over 3 hours.
This stuff
of
is
bottom time
really
left.
reminiscent of
So the
volcanic
speed is actually less than
clastic
0.1 that we have to achieve.
debris
It's just the
deposits.
terrain.
Yeah,
Yeah.
okay. Zoom partial.
Holding partial.
Thank you.
It's really
Okay,
spectacular
pilots,
there,
ship
isn't it?
has
And a
just
little
stopped.
more.
Roger that, copy. I think we'll be okay.
Beautiful.
Okay, hearing nothing, let's go full wide and I'll continue up the slope.
Sounds good.
So I've been a little bit multitasking today, but I'm not sure we've imaged this crinoid before. I think it's in the genus Proisocrinus, but that would be a different one.
Thank you, Chris.
So, Patty, do you have any good fracture jokes? Because those always crack me up.
Oh my God.
I don't know, Chris. We're going to have to cut you off.
That was bad.
That was really bad, said the pilot. We do have some vertical fractures in this material, but I don't think there's been any offset on the one that we're we're looking at. Now that we get a better view up the slope, there doesn't seem to be any continuation of offset
Zoom pink thing.
on these fractures, and you'd expect that if you had one big fracture. We have a shrimp. Surely we have a shrimp.
It was a pretty hard act to follow.
Oh.
Yeah, geologists have the worst puns. How come biologists don't have puns like this? I think it's your words are too long and complicated.
We do. We're just keeping them to ourselves.
Well, I would not take this rock for granted.
How can you
Ha ha. Gotcha.
on that? Let's go for white.
Oh my gosh.
My privileges ought to be taken away. I think somebody else's privileges ought to be taken away too.
Oh, nicely layered stuff. You know, I'm speculating out here that this is volcanic clastic debris, and I'm making all sorts of typos in my notes. But I don't know of any kind of material that could settle out of the water column in this part of the region between the trench axis and the volcanic arc that could be this coarse. We're seeing fine layers and coarse layers.
Zoom
So
yellow thing.
if this is volcanic material, and we are approximately 60 or so kilometers east of the volcanic arc, there was some
I'm gonna take a little
humongous
more zoom. If that's all right.
eruption in the volcanic arc sometime in the past
All right.
to produce this much of this material. I'm trying to keep a
Boy.
close eye on the depth at which
Just
we
couldn't quite
cross
tell
into something
what it was.
else as we go up the slope to get an
You're full
idea of
wet.
how thick this deposit is.
Okay.
But if
Wow,
it's
look at
volcanic
that.
Wanna get
plastic,
another
what we're
move
looking
underway?
at are a series of pulses of
Yeah,
eruption
that'd be good.
from an explosive
Maybe
volcano,
let's try
which
another
is
20?
typical
Sure.
of those in
Looks safe.
the
Yep.
ring of
Yep.
fire around
20
the
at
Pacific.
340 bearing.
So you would expect that kind of eruption in the
You
Mariana
know, it looks like it's coming around a little bit, maybe
Well, keep an eye
345.
on
What do you
that
think,
layer
Jeff?
Yeah.
right there.
Maybe more like
That's a very
345, 350.
a layer of very
Yeah.
thin,
Thin.
fine,
Really,
small
I don't
grain
wanna change-
material,
almost due north right
Yeah.
like a poof of.
Let's bring it
of
around
volcanic
350.
350.
Let's see how that works.
But
Yeah.
you do see some larger blocks in this. Oh, wow. I mean, this is really far from the arc.
How old would you think this would be?
Bridge.
How
this is Matt.
old? That's a question that maybe we can answer if we could see how thick this
Good.
is.
I have another move,
We have a
please.
rock from down below
We'll
that
have
may be
range
sedimentary,
20
and therefore
meters.
may be able to tell
Bearing 350
micro
and a speed of 0.2 knots,
paleontologists look at forams and things, how old that rock was deposited. And then
Good copy,
if we
Bridge,
get
thank
a
you.
rock up on top, get another age, and find out, what the layers sandwiching this would tell us in terms of when the stuff was deposited. But this is a much more interesting rock dive than yesterday. Oh, go
You
into
think?
there.
You
Yep,
think?
Yep.
There's a bit of a sponge-looking incrustation on
Where do
this
you
rock.
Where do you see
It's
that?
a
Our
little bit
geographer
blue,
sees
a
an
little on the
encrusting
left of the
sponge, maybe?
rock. There's a little.
Oh, yeah, I see what you're looking at. It's at about
Hard to know what
9
it is, but
o'clock.
something.
You want to zoom partial? See
Sure.
If we can
Yeah, you
resolve
can.
it?
Oh.
Might just be a color change.
It might just be.
No, it's something different.
Yeah.
Let me back up a little bit.
Yep. That looks.
Hard to know.
That looks like demo sponge to me. Thin encrusting demo sponge.
I have a little more zoom.
Go for it. Sorry, I slipped.
No worries.
Yeah,
Coming
just-
out partial.
Just a touch of current. Now, full white, please.
Yep.
Lost my bearings there. Shirley, do you need to see more of that?
Nope, that's good. Thank you.
Okay.
Roger.
Great. Let's go take a look at
So
this.
I think this coral on the right is different from the Metallo Gorges we've been looking at. I wonder if we could take a peek at it.
Did you hear that,
Okay, I do.
Jeff? We're going
Yeah, we'll set
to want
up
to go
for
into
this.
that. Thanks.
Don, you let me know if the move
In fact, I
goes.
think it's a black coral, not a Chrysogorges.
Looking at 65 degrees etching now, something like that. So we got a little bit of time.
All right.
Right.
Oh, golly.
Tara, let's go in partial
Roger.
until I stabilize a bit. Go a little more.
Wow.
Holding.
Okay, thank you.
Scott's thinking this is Umbellapathes, another genus of black coral.
Okay, now you can go in further.
Oh, Chris thought that too. Great minds think alike.
Coming wide.
Thanks.
Boy, you can see that layering, Patty, when you look in the background too.
Yeah, what I'm looking at right now is right below the coral, there are structures that look kind of like columnar joints, but they don't have the hexagonal surface. So I made some comments in the chat about it, but I am not sure. There certainly is layering behind,
I think
and
it's
all
time
of
to
this
start
material
pushing
looks
out.
layered. Which you wouldn't expect to find columnar
big
jointing
amphitheater
in layered deposit unless it was really hot when it got deposited. If we, oh shucks, total speculation. Nope, not gonna do it. Not gonna do it. Take it back. But clearly, all of the part of the wall that we're climbing right now looks like it's very friable, easily broken up, despite the fact you see this great layering in it. It looks like it just kind of falls apart. I'm looking for a distinct change in this type of material that might give us the upper boundary of this deposit. There are not too many corals or things attached to these rocks. Too easily broken up, huh? It's probably a pretty dynamic area.
Yeah,
There's a lot of seismicity
Yeah,
Very
Roger that.
stable.
in this
Yeah,
region.
let's hold that.
Yeah, but the thing
Not
is, we're
make
not
another
seeing
move.
any,
We're starting
like,
to get
We're not
you
seeing
know,
as
closer
much
to the
layering right
wall
now.
no. And like with the rocks that may have broken off, we're not seeing any
Yeah, it
dead
looks like we're
stuff that
about
was,
to maybe
you know, attached
18
to them
meters.
before.
Okay.
So,
Okay. That's a comfortable place.
yeah,
And the strike still seems to be 350.
looks like it.
Okay.
Now look at that. Look at those slabs up there.
Yeah.
Jeez. See, now I'm wondering why you wouldn't see lots of stuff on those slabs. So,
Uh-huh.
Tara, can we
Well,
zoom on,
these layers
swimming
look
thing?
as
Sure.
if they may be somewhat finer grained now. Oh, we have a little swimmer.
Just keep zooming. Just keep zooming.
What is this?
Just
What is this?
That's really sweet.
it's going up faster than I am.
Speedy.
Little legs going like mad.
it is going like crazy.
What is this?
I have no idea.
Okay, Scott, Chris, help.
I'm gonna go out on a limb and say paracarot, but who knows?
What's a paracarad?
Well, okay, so the isopods, amphipods, and mycetes.
That was adorable.
Okay.
See, so I left myself
that
wide
was
open. I could
slowing
be
down.
in
could
any
be
of those three,
anything.
but it could be in none of those as well.
Okay.
Nice
Oh,
photo.
cremation? Really? Oh man, I was way off on that.
I've turned a little bit to starboard just to keep an eye on you, so maybe you need to head back in towards the center
Wes
a
is
bit.
suggesting
Straighten up.
cremation, and he should know, being one of the world's experts in crematia. I thought the abdomen was a bit too long for that, but no, he's saying it's definitely cremation. So
Okay, And
If Wes Watling says that's a cremation, that's a cremation.
and unless the world's
Another kind of cremation story.
yeah, so unless the world's expert is on the phone and can talk to us about cremations, Scott, do you want to tell us a little about cremations?
Go ahead, zoom partial.
Boy.
I'll try and bring it in. You can see.
Okay.
Here is I don't remember much about the crematia.
Me
You can see there that they had that long abdomen that's got very few to no
Zooming a bit further.
swimming appendages. That's one of the reasons it's kind of herky-jerky as it's moving through the water column because it doesn't have those very well-developed swimming appendages. They have a carapace that covers, most of the front part of the body and a lot of the head. I don't remember all that much about them other than some very unusual ones from hydrothermal vents that have eye stalks. They're blind, but their eye stalks are modified into scraping structures to scrape bacteria off the rock. So I can only tell you that factoid, which has nothing to do with what we just saw, but it's an interesting one.
But you know what, Scott? I had it in the paracarids, so I wasn't that far off, was I? I mean, because it's in the I wasn't thinking cremation at all. I was thinking more mycid, but so I wasn't that far off.
And as we were zoomed in on the critter, we're not seeing any layering anymore in the rocks, but it does look like a granular surface, or it has a surface that is covered with a very thick coating of manganese oxide that gives it a granular appearance. Big question marks after all that. Brittle star. Trying to cling on for dear life. Right. Ooh, is this a brittle star?
I say yes.
Looks like one.
Must be a tough wall to climb.
This is pretty steep here.
Okay, for what?
It's impressive.
Oh, something big.
Oh, there's a stalked thing. Oh, Shirley. Oh, beautiful, Scott.
Look at
Scott,
that.
this is a
Wait,
real old
take
one.
an image of that.
How many brittle stars are on this guy? Does it only have one?
Let's go partial.
Roger.
Sort of fill the screen with the. That's good.
Oh, wow. Isn't that pretty? Oh.
Okay, to zoom a bit further.
Yes. Go ahead.
Beautiful.
Oh, this is truly, looks like,
Blossoms on a tree or something.
absolutely looks like cherry blossoms in D.C.
Sakura.
Gorgeous sponge. Coral, sorry. Oops. Don't kill me, Shirley.
No, I won't. The coral people will, though.
Yeah, I know.
Okay.
Roger. Thank you.
Don, I keep getting over to the.
Yeah, the current's still pushing you that way. Yeah.
Yeah, there's
Or
a
we're pulling
current
it,
that's pushing the
cable.
We should
the
maybe
ROV to the right.
turn a little more, turn Sirius a little bit more to the right. Like maybe
That
our
might be
wall
a
is
sponge to the
currently-
left, coming off the
Yeah,
wall.
we're heading right towards the wall.
Way
and
on the
I want to
left,
get
on
another
the bottom
swing on
screen.
sonar.
Yeah, could be.
And still, it looks
oh,
like north.
wow. Look at that.
Wow.
Ah, beautiful, beautiful. Metallic Gorgia.
Oh, look at the
Isn't that
layering.
gorgeous?
Yeah,
Oh, my
layering
goodness.
is back.
Oh.
Right, we're saying layering.
Sorry. Oh, wow. So this is right above
Something
what
for
was
everyone.
a big, massive layer, and we're at 1766. I was just trying to check to see where we started into this more granular stuff. Hang on, I gotta do subtraction. 3. Wow. So the layer of granular material that we saw right above the contact with that beautifully finely layered stuff was 33 meters below us, and now we're back into this granular material at 1766 meters.
No.
It's very
We're looking at a
fast.
little amphipod in the water column, I think. Is that an amphipod? I gotta scroll all the way
Let's
back
see.
down. Swimmer.
You mean the one that we were just looking at
Yep.
before?
Yep.
Comation?
No,
Oh.
in the water.
Oh.
Oh, wow. Look at the layers in this. Yeeps. Geology Central.
So to the left of the animal, more or less straight ahead. Yeah, so straight ahead here.
So I think we're seeing some
That.
graded bedding in these layers. We're going to zoom in a little bit and see if we can distinguish any of it. Oops.
Okay, let's zoom in. Hold down.
Holding partial.
This looks pretty uniform. Maybe
come
a
out a bit
slight
wider.
increase in coarse layers to fine layering. Okay, pilot, thank you.
You're welcome. What?
Sorry, folks, you're hearing some bells in the
Nav,
background
we should
that
probably
we
get a move underway now.
hope is a drill.
We do.
Okay, good. Fire drill. Okay.
What is the thing in the
Okay.
center?
Looks like the wall is around about 350.
What is
I'm
this?
thinking that maybe we should go north.
This looks like pieces of an organism.
Stand by.
Or maybe it's
Hard to say.
trash.
Or maybe it's
A bit more
stain
zoom.
in the rock.
It could be a
I'm looking
stain
at
on the
the thing
rock.
in the front,
Oh, that thing which
is
might be a
lie,
sponge.
which looks like a carnivorous sponge.
Sorry.
Yeah.
Ah, I
Coming
see.
back partial.
Once.
Yeah,
Yeah,
fuzzy finger. Looks like a pipe cleaner.
Full wide.
Yeah, Nav, let's go ahead and go
Oh,
due north,
wow.
20 meters.
Oh,
Sound all right to you, pilot?
Yes, indeed it does.
Ah,
Sounds
so
good.
incredible.
Bridge, this is Nav.
They may be busy with the fire drill, huh?
Hello, Bridge. Could I have another move, please? 20 meters, due north, 0.2 knots.
Wow, look at this. Looks like a Pueblo village in New
Well, I will
Mexico. right?
mention-
Isn't it though?
as we go up the slope here, that drilling on
Good copy, Bridge. Thank you.
IODP,
Which just
Leg
stands for
one.
what? What does that stand for?
this was the International
Ocean Discovery Program, or was it still called Drilling Program back
Ocean
then?
Drilling
Program.
Project.
Ah, okay.
In the Izu Arc, which is just a continuation northward of the Mariana System, we were drilling close to the trench, and we went through an Eocene volcano that had sequences of material that looked just like this.
How old would that have been?
Eocene's like
Thank you, Bridge.
30, 40 million years
Okay.
ago. Up to like late 40s.
I thought that's when the project
And
was.
it was
a long time ago.
Yeah.
it was very similar to what we're seeing in terms of material,
something big coming up ahead of you
volcanic
there.
plastics
Some
that have been
white thing. Looks
deposited
like
on
a
the flank of
candelabra
the
sponge.
volcano.
Should be coming into
So
view
don't know
now.
if that material we're looking at is is as
Good.
old.